I think with slides. I think it's something to do with
I
slides.
don't have slides because I didn't even know that I was.
No, it's fine. You don't need to.
Okay.
It'd be more
probably going to share a microphone.
Okay, so welcome to our final panel discussion. The way this is going to work is we've got a wonderful panel of 5 people from a bunch of different fields assembled to give us their perspectives from a number of different angles. I guess in the end, it turned out that we have, broadly speaking, 2 psychologists, 2 computer scientists, and 1 philosopher.
All of them walk into a bar.
Yeah. This was assembled a little bit at the last minute. For example, Jürgen Schmidhuber just emailed me this morning to say he was in town and he heard an interesting conference was on. And I said, great, do you want to be on a panel? Danny Kahneman just registered for the conference about 4 or 5 days ago and said, great, panel for you. We're still trying to convince Frances Cam, but so far she's. Oh, come on! You can do it.
This is how you can have the fee waived to become
Tom Nagel, maybe. Oh well. Anyway, so we've got a wonderful group here assembled. They will each speak for just 5 minutes or so to give some perspective and some comments. Maybe we'll take about just 1 or 2 questions after every panelist to break things up, and then we'll segue into a general discussion with questions among the panel, questions from the audience. They needn't necessarily be questions only for the 5 people who are on the panel. We've got many of our speakers from the conference nearby, and anyone else any speakers who are way back there should feel free to come up so we can end up having a general discussion of the issues, and we'll see where it goes. Anyway, as our first panelist, we've got a very promising young psychologist named Daniel Kahneman, who is doing, I believe he's been doing some very interesting work suggesting that just possibly humans may not be quite as rational as we thought they were. But he's going to give us his perspective on the conference.
Well,
Microphone.
is it? It's on? Okay, good. Well, there's a word that's been used a great deal in this conference. It's the word intuition, moral intuitions. And I was impressed by at least how little the use of that word corresponds to what I think about when I think about intuition. So there are intuitions, moral intuitions, roughly of 2 major kinds. There is one about statements. So that when we hear the statements that a capacity for suffering means that there are rights if an entity has capacity for suffering, that is an intuitively compelling statement, and we tend to accept it. So statements we tend to accept or reject. But there are also intuitions about cases, about events, about real things that happen. And those are not about accepting or not accepting. They are largely about an emotional response of indignation or more or less indignation, or approval, or in some cases, awe. To some extent, I think, when we think about the future of AI, intuitions about cases should be taken very seriously. And they should be taken very seriously because of their political significance. Because the public is going to respond to cases. It's going to respond to things like a self-driving car killing someone, in an example that was given. And you know, from my perspective, of course, both kinds of intuitions are terminally incoherent. I mean, and they're incoherent within themselves. Our intuition about statements are not coherent. Otherwise, the ethics problem, you know, would have been solved. And our intuitions about cases are not coherent, and there is no clear relationship between our intuitions about cases and about statements. Let me give you an example. So, psychologists love the trolley problem, which has been mentioned here several times. And why psychologists love the trolley problem in particular is because it is a case. It feels like a case, and it arouses emotion. It's a very different thing than just agreeing or not agreeing there is an emotional response to these scenarios. And the emotional response, it has several characteristics. One of the characteristics is conflict. It's not simple. None of these cases are simple, and some of them are really very, very difficult to deal with. And I was thinking that when we think of a self-driving car faced with a trolley problem, with a trolley-like problem, one thing that is sort of appalling, almost horrifying, regardless of how the self-driving car solves the problem, is that it will solve the problem instantly. And there is an element missing, that is to solve the trolley problem without feeling horror. And presumably that AI will not feel horror. There is something missing. And the response, I think, is going to be that regardless of what the self-driving car decides, we're not going to like it. There's going to be a sense that there is something wrong about that decision, regardless of what it was, because it was not accompanied by conflict. It was computed, and then, whatever maximized whatever function is what was chosen. And so we're going to have a lot of difficulty with that. And there are going to be, it's an example of the kind of thing where intuitions about cases, about that event, really do not necessarily correspond to a moral, to a well-defined system of ethics or to any set of particular rules. One characteristic of intuitions about cases in particular is the dependence on essentially irrelevant factors. And that's, to a large extent, is what makes them incoherent. So I'll mention only one, and that's appearance. And what is the role of the appearance of the agent in our intuitions about the agent's moral behavior or moral rights? And I think it's profound. I mean, just imagine that you have a bunch of lifelike models of squirrels. You know that they're models, but they're on the floor. And then there is somebody taking a hammer to them. To those little statues of squirrels. Is it the same as somebody taking a hammer to electric trains? And I submit that there is a difference, because we feel very differently about things that look like living things, that we associate with living things, that we associate with emotion. So this is going to make a very big difference. And it shouldn't. Now, our intuitions about the rights of AI agents are going, I think, to depend critically on whether they are designed to look like us. I find it very difficult. I mean, when we're talking about a capacity for suffering, so let me go back to that. A capacity for suffering, how would I know that this AI is suffering? How would that AI communicate to me its capacity for suffering? And I can tell you, I was sort of trying to imagine, does a program, a very elaborate program, have a capacity for suffering? Now, in a sense, those who say that an AI will have capacity for suffering are giving a positive response to this question. And yet, I find myself in a lot of difficulty feeling empathy for a program because I'm told that it has a capacity for suffering. We depend very critically in our intuitions about the rights of people, about the obligations, about the duties. We depend very much on what they look like, on how they express emotion, on how they express their suffering, on whether they compellingly convince us that they're conscious, and convincing me that your convincing me that you are conscious depends a great deal on your looking essentially like me. I mean, there is a difficulty imagining the consciousness of something that I cannot empathize with. And empathy, which is built in, which is in the emotional substrate, empathy depends on irrelevant factors, on factors that are not really or should not be morally consequential. So that's the puzzle that I was left with. That in a lot of discussions, notably this afternoon on the rights of AIs and so on, every one of these statements looked compelling. I felt I accepted the intuitions about, what determines whether AIs have or do not have rights. And at the same time, I wasn't at all sure that my intuitions about cases or about events would actually correspond to those intuitions, because I wasn't sure about whether I would get the emotional connection that is, I think, quite essential to moral intuitions of any kind. And those were my 5 minutes.
Okay, John?
Thanks for that. So there's this difference between what we think is morally appropriate and then what we're going to empathize with and so respond to. But those things seem to me, at least, and you know a lot more about this than I, that they're extremely malleable. So I feel empathy for all sorts of weird sci-fi characters that are described in strange ways or in movies. I feel bad for Wall-E, which is just, I know, not is it just a representation of something that's purely algorithmic. I know that it's actually not a real thing, but I feel sadness for it. When I see people kick Big Dog, which is this robotic dog, I feel like, no, don't do that. And we have people that at least claim that our sphere of empathy has expanded over the years. And so I wonder if you think there's any prospects for just changing ourselves so we'll feel empathy for the right kind of things.
I think Wall-E had, there were enough cues so that it looked emotional. You felt for Wall-E, you empathized. And those are, so now the conditions for which are the kinds of beings with which we can empathize, that's going to be the issue that's going to determine our intuitions about cases, which I think in turn is likely to determine our political intuitions. I mean, the response of the public to cases and possibly to rules.
Take one more? Yeah.
I wonder what your thoughts would be on two things. The first is what impact it would have socially on humans if we were to try to override the empathy we feel for kicking a robotic dog, for example. Like if we were to say it's fine to kick a robotic dog because it's just a robot, is it harmful? Like, for example, we spoke the other day about rape in a virtual reality world, right? And the potential detrimental effects of that experience. So that, and then also just understanding the relationship between AI and humanity in terms of conflict of interest. Like, for example, if you've seen the movie Ex Machina, if Ava had been treated nicely, maybe she didn't have to stab her maker and lock her lover in a box.
Well, as in a way, it's similar to the previous question. Our intuitions about these things are indeed quite malleable. And so, we have a lot of instances where people view other people as not having any moral rights and feel absolutely no empathy for these other people. There are historic precedent, there are current instances of that sort of thing. So, indeed, this is malleable. We can desensitize. Whether we can, with equal ease, sensitize, that I'm not sure of. That is, we need a minimum of cues. And in all the examples that we have, including Ex Machina and Wall-E, there are very good cues so that we're horrified at the end of Ex Machina when when she locks her lover and sort of walks out. Let's see, I forget your second question.
It's okay. Just have sorry, one question per person. Sorry.
Yeah, we have to.
One question per person. We're trying to get in our honorary sixth panelist, Francis.
I don't know what he's talking about. You can lock him up. But anyway, the thing is that, Professor Kahneman, there might be a distinction between hypothetical cases that are considered and actual cases. And I heard you talking about actual cases, because very often when you think about hypothetical trolley problems, you don't have any conflict at all. You may have an immediate intuitive judgment, which you then try to give a rational justification for in terms of a principle, which you deny there is, but anyway. Because the judgments are usually about permissibility. Is it permissible to do this? I heard you talking about what might be real cases. You said if an actual AI-driven car runs into somebody, how will people respond? And it may be that when I'm in an actual situation, if I were, where I had to turn a trolley, though I knew it would be permissible, my conflict will be about, will I do this or not? Because many people say it's not obligatory to do it. And in an actual situation, to decide on what to do is a different thing than to consider a hypothetical. I'm wondering if that could, modify some of what you said.
No, I mean, when I was talking of cases, I wasn't talking of actual cases, and I was not taking the perspective of the individual who must make the decision. Okay. And from that point of view, the perspective of an observer of an actual cases or of the reader of a compelling description of an actual case, that's what I was talking about. And in some of the trolley problems, indeed, there is an immediate intuition, and it seems easy to justify. In other problems, like the fat man on the bridge, there is conflict, and there is, and the sensation is, this is why it's become such an important problem in psychology, actually, in social psychology. The trolley problem is because of that conflict. Now, I didn't deny the existence of principles. I was talking of principles when I was talking of intuitions about statements, and we clearly have them. I made the claim, with which I'm not sure you would agree, that I made the claim that these are probably not internally consistent.
Okay, we should move on to our second speaker, who's Susan Schneider from the University of Connecticut in philosophy. Susan has done a lot of work in the philosophy of cognitive science and the philosophy of mind, with a book on the language of thought, and a lot of work in the metaphysics of mind. But lately she's been doing a whole lot of really interesting work on technology and the future of AI, as well as connected issues such as mind uploading and the universe as a simulation and so on, which is very much worth checking out. So Susan.
Thank you. So I have 5 minutes. I'm going to say a few quick things about machine consciousness, emphasizing the ethics of it all. So just so we're all on the same page, here's what I mean by conscious. Every moment of your waking life, and even when you're dreaming, there's something it feels like from the inside to be you. So when you see the rich hues of a sunset or smell the aroma of your morning coffee, you are having conscious experience. So today, a lot of us have worried about whether AI can be conscious. I'm going to emphasize why it matters. First, as earlier speakers noted, suppose we create sophisticated AI, say AGI, artificial general intelligence, and it is conscious. Then it can suffer and feel a range of emotions. But we've created it to work for us. And to force it to fight our wars or clean our homes, isn't that just slavery? And wouldn't destroying it, as opposed to just temporarily unplugging it, be murder? Further, wouldn't developing AGI that was conscious be an ethical muddle and not a good investment? Now, though, suppose, on the other hand, that AI is not conscious. I want to emphasize that this is a game changer, too, for a number of reasons. First of all, the media has been talking a lot about being in a computer simulation. Okay, the good news is if AI can't be conscious, you're not in a simulation right now because you would be AI if you were in a simulation. So congratulations. All right. But other issues also. We can't merge with machines in this case the way people like Ray Kurzweil envision. Replacing parts of your biological brain with microchips would cause you to lose awareness. And it's not clear at all that you would be able to survive brain uploading. I mean, if you're no longer conscious, then I think there's a good argument for that upload not being you, but being a computational duplicate of you, at least in terms of certain information processing capacities. And let's also think about this issue on a more cosmic scale. So some say that the next phase in the evolution of intelligence on Earth will be artificial intelligence. You and I, how we live and experience the world right now, we are just an intermediate step to AI. Synthetic intelligence will supplant biological intelligence. Indeed, in my work with NASA, I've urged that a similar phenomenon may have played out on other planets already. The greatest alien intelligences, if they exist at all, may be post-biological, being AIs that evolved from biological civilizations like our own. But if it doesn't feel like anything to be an AI, we had better ask whether a universe full of intelligent, non-conscious machines is more valuable than biological life like us, even if it's radically less intelligent than super-intelligent AI. So I hope my quick blurb has convinced you that the question of whether AI is conscious or not concerns the very future of humanity. As I like to tell my students, when it comes to AI, philosophy is actually a matter of life and death. So what can we do? Well, I think we need to figure out a way to test and determine whether AI can be conscious. But I just want to emphasize this will be difficult for two reasons. First, earlier speakers pointed this out already. We know biological beings can be conscious, and we also have a sense that non-human animals are conscious because they're neurophysiologically similar to us. But the question is very difficult, how to know whether something that's made of a different stuff entirely, microchips of some sort, could have experience. But suppose, for a moment, we do find out microchips are the right stuff. I want to emphasize an unappreciated problem that emerges. Consider superintelligence. So again, superintelligent AI is hypothetical AI that's able to outthink us in every domain, social skills, scientific reasoning, and more. The problem is this. It may be more efficient for a superintelligence or even just an AGI that's not a superintelligence to eliminate consciousness altogether. Think about how consciousness works in humans. Only a small percentage of our human mental processing is actually conscious at any given time. Most of our thinking is non-conscious computation. Consciousness is correlated with novel learning tasks that require slow, deliberate focus. So think about how focused you were when you first learned to drive, as opposed to how unconscious you might be when you drive nowadays on a familiar route. A superintelligence surpasses expert-level knowledge in every domain, having rapid-fire computations that could range over the entire planet and encompass the entire internet. What would be novel to it that would require slow, deliberative focus? Wouldn't it have already mastered everything? So we need a way to determine when and even whether a machine needs to be conscious in the first place. Some may, but some may not. Thank you.
I would like you to clarify a couple of assumptions you seem to be making in your speech. First of all, when you spoke about consciousness, you seem to be associating it with ability to feel. Now, there are humans who, due to neurological damage, do not have the ability to feel emotion. Then, would you then call them unconscious, according to your own definition? Question number 2. You seem to state that an AI who is bound to serve humanity is equivalent to a slave. Now, the whole field of AI safety proclaims that if an AI does indeed feel like a slave, then purely because of its superior power, it would break free and exterminate us or do something that we do not want it to do. Therefore, can you elucidate your definition of slavery according to this definition? Does it boil down to a question of free will, or does it boil down to an instance of unfriendly AI who considers humans to be immoral in their actions towards itself?
Okay, you raised a lot of issues there. So I'm not saying that hypothetically a being that couldn't feel emotion would lack consciousness. Clearly, emotion is closely connected to our awareness. But in my 5 minutes, I certainly didn't mean to be making any sweeping claims. Now, you raised a lot of issues that you're asking about AI safety, and are you asking about the role of consciousness and free will in AI safety, or? Okay, so I think I'll leave consciousness intuitive. I hope that at this moment it feels like something to be you, and you can define it introspectively. Philosophers have fought for a long time over precisely how to define consciousness. Slavery in relation to AI, it's a very interesting issue that I think some of the earlier speakers addressed. I was using it in just a loose sense by analogy with slavery, that we do know. So I'll just leave it at that.
One more, Andrew.
Hi, thanks. So towards the end, you were talking about whether an AI would need consciousness at all and the function of consciousness. And one thing you were saying is that one of the functions of consciousness seems to be associated with the with novel information. And perhaps if an AI had access to tons of information and were able to use that and had mastery over that, then it wouldn't need consciousness. And I guess I was wondering if you could say a bit more about that, because it seems that, as far as we can tell, consciousness has multiple functional roles, one of which might be executive decision-making or deliberating over what to actually do. And if we're thinking about artificial general intelligence, then if it's the case that that is one of the functional roles of consciousness, it doesn't seem obvious that that would be lacking in an AGI.
Mm-hmm. Yeah, I'm saying it's an issue that's open for investigation. I think, I was suggesting that consciousness is reserved for slow deliberative processing, and I think the question is, which AGI systems, if any, would need consciousness? So it could be that slowness and novelty are just not part of the information processing needs of the particular AGI in question. So I think we have to just investigate the issue.
Okay, let's move on now to our third speaker, who's Jürgen Schmidhuber. Jürgen is an AI researcher who is director of the Swiss AI Lab in Lugano, very well known for his work over the years on deep neural networks, recurrent neural networks, deep neural networks of all kinds, where he's been a pioneer since, I guess, the early 90s. He's also done some really interesting work on universal AI, including designing the wonderful Gödel machines, which are, provably more powerful than all kinds of other AI systems, and unfortunately not fully implemented just yet. But over to you, Jürgen.
Thanks so much, David. first I had no idea what I'm going to talk about, but now I can just respond to Susan.
Talk about last minute.
Yeah. Let me briefly explain how we already have little conscious artificial systems in our lab and have had them for a couple of years. And in those systems, consciousness is just a natural side effect, a byproduct of data compression during problem solving. Why that? So to build a general problem solver, that is what we have been working on for many decades, and we are getting closer and closer. You need something like a general purpose computer, which in our case usually is a recurrent neural network, because in this universe you want to have a computational device which exploits the physical constraints as much as possible, so that you want to have lots of processors in a small volume connected through many short wires and few long wires to minimize communication costs. So you have a problem solver where video streams in and pain signals and auditory signals and whatever, and it translates that somehow into movements, action sequences, and it gets reward, positive signals, feedback signals for achieving goals. So there's some utility function that it wants to maximize that, or you give it one goal after another, and then over time it becomes a more general problem solver. Now this guy has a little helper, which is another recurrent neural network, which is a model of the world. And what does it do? It takes all the data ever observed, all the inputs that ever were observed in response to the actions that were generated by the control module. The controller and the model, they interact in a certain sense, and the controller is shaping the history of inputs coming in, which then the model tries to predict, to compress through predictive coding. Why does it want to do that? Because it wants to figure out the few regular things in the world. Now, we have a very friendly environment, and lots of things are repetitive and repeat themselves, and so this means always that you can more compactly describe them by devising a little program, a little recurrent subnetwork, which can encode these things through predictive coding, for example. So you, for example, have videos of falling apples, 100 apples fall down like this, and then the raw data is like that. But if you understand gravity, you have a little recurrent network which implements the predictions according to gravity, then you can predict how these apples come down, and you can greatly, greatly compress the video. And all of physics and all of science and all of chemistry is really about compression progress, about finding short descriptions of the data, which you then often can reuse through the controller to solve problems better. Now, what is this unsupervised module doing, which is doing the compression of all the data ever observed in response to all your actions ever executed? So you better store them all. We don't know whether humans store them all, but a robot should store them all because storage is cheap, and you can easily store 100 years of high-resolution video in current devices. And then you want to find the regularities during sleep, for example. You work on all this data, and you try to compress, basically. Which means that all the things that frequently occur in your environment, such as faces, for example, are efficiently encoded in some sort of prototype phase. So a new phase comes along such that you have to encode only the deviations from the prototype phase that you already have. Same for glasses, same for everything that is happening in your world, the words, the repetitive signals that are coming out of the mouths of other people, and so on. And there's one thing which is always present as you, as the actor, are interacting with the world, which is the actor itself. So it's really, really useful to set aside a couple of neurons and synapses which encode this representation of yourself as you're interacting in many different ways with the world. So as the data compression of the entire history of your life is progressing, you are inventing all these little neural symbols which stand for the stuff that frequently occurs, which helps you to better compress, including your self symbols. So you have symbols that stand for yourself. Now, whenever the controller is trying to solve a new problem by finding a weight matrix, a program essentially, that leads to an action sequence that solves that problem, it has a search space, and it can reduce that search space by looking at this model, which already knows a lot about the world and has algorithmic information about how the world works, and you can reuse that in a good way to come up with new solutions more quickly. And as it is doing that, sometimes it's waking up these self symbols, for example. Then you are thinking of yourself. And our robots are thinking of themselves. They have self symbols which wake up just as a natural byproduct of data compression through during problem solving. And then, of course, what is happening, as you correctly stated, some of the things that you, some of the skills and the observation sequences and the pattern recognition techniques that you have developed over the time, they become automatic. So they become kind of unconscious, and only the new things where you're still working on how to improve the performance of the controller, the problem solver, they are still undergoing a search process where you want to find a good combination of weights that solves the new problem without destroying the previous skills that you have learned. And so our first system of that type, I had one in 1991. It was a recurrent neural network. It just learned to compress the data, an unsupervised learning network, which learned to compress the observations. And everything that this guy didn't understand, it sent up to a high-level guy. Unpredictable stuff went up to a higher-level guy, which then tried to find higher-level irregularities, and then maybe found additional compressibilities and developed internal representations, which the lower-level guy, the automatizer, as opposed to the conscious chunker, could learn to imitate, such that the previously conscious stuff during problem solving and search became unconscious by imitating just the problems that the high-level guy found. And so we have all of these things going on, and and they have been going on for many years. So I would say, from a technical and practical perspective, the issues of unsupervised learning and consciousness are solved, and we already have them in our artificial beings.
On this one. Oh, do you want to respond?
I think there's nothing to
How
respond.
could I not say something? I mean, everybody has a definition of consciousness, and I mean, that's why I said let's just do it introspectively, because we all know what that means. So we have another proposal why, that consciousness is a side effect of data compression, and I'll just say what we need, given the ethical significance of machine consciousness, is a dialogue between scientists, philosophers, and others to really figure out what the heck consciousness is from a scientific perspective. And then we need to figure out under what conditions we want AI to even be conscious. So I'll just leave it at that.
I think I saw Julian.
Thank you. So Jürgen, what if I tell you that the little program you describe right now, which is a very clever program, a nice principle and all that, what if I tell you that that's not conscious at all? I mean, it behaves in certain sense conscious-like, but it doesn't actually feel like anything to be that program. And what's more, what if I tell you that, you can disagree with me, but there's no way you can convince me, because the only way I could... the only way you could possibly convince me that something actually had phenomenal consciousness would be if I could sort of see myself in it. That I could sort of see that, well, the thing is sort of like me, and therefore it probably feels like something to be like it. Is that a problem for your program or everything we're talking about here?
This was Julian Tugelius, my former postdoc, now professor at NYU. I think now it's time to make a little confession. My company, Nasons, we are building androids, and I'm a prototype. And And we are not commercializing our products yet because we still allow suggestions for improvements. And let me tell you, we have a long, long list of suggestions for improvements. But there will be a version 2.0. And now let me try to answer to Julian's question. While I'm saying all the things that I'm saying, I'm totally unconscious. But I'm really good at faking it. At faking my consciousness, and we leave it at that.
Okay, we should move on. Next. I'd say he could be doing a better job at faking consciousness. Okay.
The zombie gauntlet has been thrown.
The next speaker is Jan Tallinn. Jan is was one of the developers of Skype and has become a really major force in the community for thinking about the future of AI. He's been a big force in the Cambridge Center for Existential Risk, as well as in the Future for Life Institute. And over to Jan.
Thank you, David. I am in the middle of establishing a personal record here. The personal record is my shortest visit to the US. I have this personal policy of whenever I displace my atoms by the width of one ocean, I try to stick around for like at least 10 days or so to kind of justify the financial and moral expense. But I was really torn between like should I kind of violate my policy in order to join the like this amazing roster of speakers that David had amassed somehow here, and including my scientific hero who's sitting just next to me here, and but now I'm really confident that I did make a right decision. So in the spirit of this like closing panel, I would just like go over the notes that I made during this conference to basically kind of try to convince myself and you that it was the right decision. So, for example, there were like really nice nuggets of insights that I hadn't thought of before. Now, starting from like Stephen Wolfram, who's a friend, and he mentioned Wolfram tones as something that action musicians go to for creative insights or creative ideas. And this is like a great card to have in my pocket when people come to me that saying that, well, what about creativity? Isn't that something that will always distinguish us from computers? Also, like today's presentation from Stuart Russell, who I really need to think that we need to clone. The ideas that the denial of risks led largely to the demise of nuclear industry, which is like really great to bring up when we talk about AI risks in AI, kind of denying AI risks. Also, the idea of starting to build uncertainty about objectives to AI was great insight, I think. And Eliezer's point about Sorcerer's Apprentice movie actually being the correct representation of what's happening, not the Terminator. Now, I also like kind of really appreciated the mix of short-term concerns and long-term concerns. I think it's really important to kind of, I think as Eliezer pointed out, like a really sharp distinction and not really delude ourselves that addressing short-term concerns would actually buy us much over when we really want to figure out how to survive the long-term issues. Perhaps we could find ways to basically make a transition, as Stuart Russell pointed out, that perhaps the sort of industry interest in creating really more and more autonomous systems that can function in unforeseen situations might transfer over to something that could be useful for sort of super intelligent regime. But it's still important to keep in mind that there is a distinction between talking about human creations and machine creations that were created by machines, that were created by machines, that were created by machines, and so forth. So like when we are talking about things about, what about moral rights of AIs and consciousness in AI. And then it's important to keep in mind we're probably talking about human creations, not machine creations. But that's still, I think it's valuable. Like, one of my favorite blogs that I can't just recommend enough is Star Slate Codex, and there Scott Alexander, the author, pointed out that like we really shouldn't have the dilemma of like how much should we spend our resources on thinking about AI safety short term versus long term, etc. Like if we can afford a $100 million boxing match, it doesn't really seem that we are on the kind of Pareto optimal frontier where we have to make kind of really like sharp, like really careful concept of spending decisions when it comes to future technological risks, reducing the risks from future technology. So yeah, one risk, myself, I really kind of focused on long-term risks, but I'm really happy that people are working on the short-term issues, and one, like the autonomous weapons. Peter Alzaro's, so as someone who knows someone who has this kind of dubious achievement of from the 90s of ending up creating a record in an antivirus database under description of a virus of unknown Eastern European origin. It's really important insight that by creating increasingly autonomous weapons and thus disentangling the scaling of offensive capability from the number of 18-year-olds that you have as an sort of institution, we might be creating a similar situation as Peter said, that we might create sort of similar regime that we have with computer viruses, where like individual people without attribution can cause global damage. And yeah, like I said, it's great that people are thinking about short-term issues. I kind of think of it as I'm really glad that people are working on global warming, for example, or like reducing the effects of global warming. I don't think that global warming is going to kind of end the world, but I'm not fully sure. And same thing is like with like there is like debate happening even within like AI safety circles, like the soft takeoff versus hard takeoff scenario. Like, and when there are, like myself, I do believe, like looking at where the trajectory of AI research is going, I do think that hard takeoff seems more likely to me, and also the creation of non-human-like agents also seems more likely to me than the alternatives. But I'm not sure. I'm certainly willing to give like at least single-digit percentage points to the alternatives. So if in case I'm right, in case I'm wrong, I'm just really glad that people are kind of taking up this particular pattern. Right. Oh, actually, let me end this thing that like I've been really over the last few years I've been kind of focusing on a few things. Like one is trying to kind of remove various bottlenecks from the AI risk and kind of X-risk sort of community or like world's capability to address X-risks. And I'm really glad to see that this conference actually is a great data point that these bottlenecks are being lifted. Like not least the AI careers lunch that we had today, that there was like a really impressive turnout there. So I'm really glad that young people are getting interested in these topics. And just before this panel, I was really glad to witness the sort of friendly and heated discussion between Eliezer here and Jan there, which I've been trying to facilitate by, and also having these discussions with Jürgen, my friend Jürgen there, every once in a while, facilitate as a kind of matter of tactics. I've been kind of investing in AI companies in order to get a ticket to hang around in their kitchens and have these conversations. And I think as a outgrowth of that approach, the partnership of AI, for example. It's as far as I know, it was a DeepMind's sort of initiative originally, and I'm glad that it is bearing fruits. It wasn't. Oh, sorry. Okay. So like, no credit for me then. Right. So yeah. In closing, I think it's valuable to think of AI research in the world as a search for the best possible future for humanity, with the important caveat that we are likely to irrevocably commit to the first result that we find. Therefore, let's be really careful about this search. Let's improve the processes that go into that.
Question on this? If there's someone with a question, wave your hand. Otherwise, okay, can move on to the. Was it one? John. Yeah.
Could you summarize what how the exchange between Eliezer and Jan went? The rest of us missed.
That would be difficult. Well, it really was as from like there were a few topics there. Like one topic that seems to be like sort of constant disagreement between Jan and various other people here in this room is like how strongly are the instrumental goals that fall out from your kind of overall goal sort of likely to emerge. Like I think Jan's point is that the instrumental goals have to do a lot with how humans treat our objectives. Like I'm not really doing justice to this right now, but and the counterpoint is that no, this just fall out. As Stuart says, it's really hard to deliver milk if you're dead. So you try not to be dead if your goal is to deliver milk. So you don't have to be afraid of death. You just like avoid it because you have some other goals. So that I think that was one topic that we discussed, and there were other. I think one important thing that Eliezer pointed out that really need this regime change between like how AIs are developed now, and how basically make sure the culture is closer to how cryptography is being developed now. The idea is that instead of just trying to do things that seem to work and be useful, let's just try to poke holes in various engineering approaches and see how they might fail. Because we really need the end result to be really robust and beneficial.
Let's go to Jan quickly. I think he's got something directly on this.
Yeah, it was a very interesting discussion with Eliezer. But there's one point. I mean, there are points that we discussed, but we didn't quite disagree, and then there are points where at least one point that we disagreed strongly. And I said, as long as we're stuck with supervised learning, there is no danger of any AI becoming, sort of life-threatening, if you want, sort of globally life-threatening. And Eliezer seemed to disagree. You seem to disagree as well. And we haven't. It was time to kind of come into this room, and so we didn't finish that discussion. But that was clearly a point of dissension.
Can you set the record straight on how the partnership got started?
It was actually a discussion. So it turns out several people within the various companies were interested in doing this independently, and it started as a discussion between me and Demis Hassabis.
Yeah, it was in January, right? Or like?
No. This was before.
It was before
we're talking, summer 2015, and then there was a first meeting at NIPS in December 2015 when Eric Horvitz kind of came on board and Ralph Fabric as well. And then in January we had the meeting here. February we had the meeting here at NYU where we had like the first kind of founding meeting with all the members. IBM kind of joined at that point. And Eric kind of Horvitz from MSR took it upon himself to kind of run the show a little bit together with Mustafa Suleyman from DeepMind, because he had been thinking about those questions for decades essentially. So he was kind of he felt strongly that he could play a role there, and so that's how it started. But really, all of those people were thinking about the same thing about the same time, and it kind of coalesced.
Yeah, thank you for doing that.
Let's get one more quickly from Virginia.
Just following up on your comment on the bottlenecks for existential risks, could you elaborate a bit more on which kind of risks do you think are the biggest bottlenecks at the moment?
Oh, like when I meant bottlenecks, I perhaps didn't have enough time to elaborate. So thank you for the question. Like I've seen that whole existential risk industry in the world has had following bottlenecks. It started with a reputational bottleneck, like in 2008 or so when I joined. That there was like a few people in California, and their messages didn't really resonate because it was really easy to dismiss them on reputational grounds, or like just didn't have like proper academic credentials, etc. So I think that situation has greatly improved now. It's very hard to make the case that call like people like Stephen Hawking and the list of British scientists, like who is who in our like Cambridge Centre advisory board as people who don't know what they're talking about. So the next bottleneck was financial bottleneck, and it still is a bottleneck in the sense that the finances are not distributed evenly in the existential risk ecosystem. So I do think the MIRI is right now the kind of the best use for marginal dollar, in my opinion. Like you should do your own research. And the next one is going to be like talent bottleneck, and it's really great to see that there's progress there as well. Now, to your question, I don't have enough. Like I gotta take all the existential risk reduction that I can get. So I don't want to kind of discourage people to work on other things than like AI risk. I just focus on AI risk for two reasons. One is that so like I really encourage people to work on things like biorisk and nano risk, even nuclear. Like first of all, my background just is computer science and physics. So I do think that it's I can make a bigger contribution in AI safety than in biology that I don't really know much about.
Okay, I think we should probably move on.
All right.
Okay, our final panelist is an NYU local, Gary Marcus. Gary, I guess, is both a psychologist and an AI researcher. You all know Gary's books in psychology and foundations of cognitive science, such as The Algebraic Mind, and books for a general audience, such as Kluge and Guitar Zero, in which he starts off totally unable to play the guitar, and by the end of the book attains the guitar singularity. More recently, he's co-founded an AI machine learning company, Geometric Intelligence, that's doing all kinds of wonderful things that Gary can't tell you about, and he'll give us his perspective on the ethics of AI.
So I made a title, Which Moment in the Future History of AI Should We Most Worry About? I'll give you my answer at the end. So this is Alexander, my son, who's not quite 4 years old. And if you think of him as a cognitive system, he's pretty sophisticated. He has essentially complete linguistic capacities. He can understand and produce counterfactuals. He has a well-developed, though imperfect, capacity to reason about the physical world, an outstanding capacity to acquire and even invent new motor actions, strong ability to transfer knowledge between domains into novel situations. If I could do that with my company, I think I would be rich and famous. Here he is. Standing on a glass coffee table, or I guess this is the end of a motor action he's trying to acquire, and the landing strip, otherwise known as the couch, is on the other side. I was testing out my new camera, so you can see basically what was going on. There is, however, just one catch. He made it this time, but maybe the emphasis is on this time. This cute child's cognitive abilities are uneven. Even if his linguistic and motor capacities are great, his capacity for assessing risk is only modestly well correlated with reality. And he has no concern, and I see this as an ethical failing on his part, for what his parents will think if he injures himself during exploratory play. There are other lapses that happen every day. This also from my new camera. This is my daughter. It would seem that about 3 to 10 times a day there are disputes about property rights, and they inevitably end badly. My understanding, not owning any of the older variety of the species, is that it's only going to get worse. As they become teenagers, the teenage brain's still under construction. Teenagers have even stronger reasoning and language skills, well beyond anything we can do in AI. They have adult-like pleasure systems that induce them to do things like drive very quickly. They have their own set of inhibitory challenges, and unfortunately, they have a greater capacity than toddlers to operate heavy machinery. So that's the first, that's the lead in here. We'll come back to it. In a way, the point I want to make today is just this. Cognition is not homogeneous. So there are abstractions where what we're looking for is a particular threshold moment of strong superintelligence. But I think we all know at some level that intelligence is really a multidimensional variable. It's not a one-dimensional variable. And I just want to meditate on that. I don't think it's a surprise to anybody in this room, but it hasn't been the focus here, and I think it's worth thinking about what's at stake. So there are many things that go in intelligence. I'm no more going to define intelligence than you define consciousness, just sort of provisionally. I don't want to get stuck on it. But one way to define intelligence would be something like a capacity to coordinate a vast array of cognitive tools like induction, deduction, pattern recognition, and so forth. We're doing really well on the pattern recognition part right now in AI, but maybe not so well on other pieces like physical reasoning and planning. Computers, I mean, you can think that there's a multi-dimensional space defined by these different sub-dimensions of intelligence, like your clock speed or your memory capacity. And so humans and computers already occupy very different parts of the cognitive space. And I think one theme that's come up is we have no idea what these future AGI machines are going to think like. Where are they going to be in this space, which is, of course, much more complicated than what I've drawn here. And even different AI systems radically differ from each other in terms of their composition. There's been a lot of sort of talking about AI in generic ways, but just think about like the differences between Watson and AlexNet. AlexNet was one of the groundbreaking image recognition things. Watson from IBM, you all know, or memory networks that Jan LeCun mentioned in his talk, and there's a similar paper in Nature by DeepMind this week. These things have very different properties, like some of them have read-write buffers, some of them have modular structures, some of them don't. They're very different cognitive systems. So in recent years, we've seen we've seen huge advances in hardware. So as Jürgen said, it's trivial to have terabytes of memory. You could have 100 years of video. We have enormous numbers of floating point operations per second, and enormous progress in certain aspects of AI, like image recognition, speech recognition, and so forth. Right now, though, and this is a technical term, we know diddly squat about how to make machines that can actually reason ethically, except maybe in very limited toy contexts where we define some very narrow world. So you could take, for example, the average teenager. This is a new variation on a Turing test, I suppose, I'm proposing online. Watch a movie and tell me, are this character's actions ethical or not? Any teenager can do this in a vast variety of Hollywood movies, let's say, and probably a lot of other movies. We have no idea how to make a machine to do that at this point. That could do the segmentation of things into individual characters that are time-space worms that evolve over time and then have actions and so forth. It's hard enough, in fact, to program an autonomous vehicle to recognize the simple concept of a truck on a sunny day, as we all know from the first Tesla fatality. And we have, as present, I think it's important to be realistic, so far as I know, no serious proposal for how we could actually code something like Asimov's laws. And I think we all know that Asimov's laws themselves are too primitive, but how do you encode a concept like harm? And I think Eliezer was pointing in some similar directions in such a way that it could be reliably evaluated relative to real-world context. We don't have tools for that. The most impressive techniques we have for learning right now, and I should say we're going to have learning systems for ethics. We're never going to hard code all of the specific contexts that we need things. So we have to have learning systems. Well, our best learning systems are things like deep learning. They involve huge numbers of parameters. They require huge amounts of data, and they're still not good enough for mission-critical jobs like driving. Like NVIDIA made a big splash with this thing that was trained for 72 hours, and it could drive around and had an autonomy rate of 98%, but you read the fine print, and that means autonomy is 98%, you don't have to touch the wheel, and a 10-minute commute in New Jersey, right? If you scale that up to across, a million driverless cars, it becomes a lot of fatality. A friend of mine made this, and I turned it into a T-shirt. Don't worry, killer robot, I'm really a starfish. It's a reminder of how easy it is to fool a deep learning system. And I don't mean to pick on deep learning systems. There aren't any other systems that are any better. In fact, deep learning systems are probably the best we've got right now. But it's easy to find, for example, textures that fool them into thinking that they're objects. There is no high-level reasoning about what's going on. And most importantly, these systems, for now, still lack ways of representing and acquiring abstract knowledge of the sort that any ethicist would take for granted just to get the conversation started. Notions like agent or harm or value or perpetrator or victim or causality. We have no idea how to learn over those kinds of entities. In any given domain right now, results are impressive. So here's a captioning system that was in the front page of the New York Times. You put in a picture, you get out text, a person riding a motorcycle on a dirt road, and you're very impressed. But if you look in the fine print, you always find really bizarre mistakes. This is my Oliver Sacks mistake. The man who mistook his wife for a hat. This is the program that mistook a parking sign for a refrigerator filled with lots of food and drinks. In closed tasks, where there's only 1,000 categories, these systems do pretty well. But in open-ended tasks, there are always lots of bizarre errors. And there's no concept, for example, of a refrigerator, a bumper sticker, or a parking sign. There's no serious capacity for compositional reasoning over those entities. And it even gets worse. It would get worse if you got to something like a compositional concept, like a mild harm caused inadvertently while trying to save someone's life. If we're really going to do the kinds of ethical reasoning that we're talking about in machines, we need to have systems that can learn over those categories, and we just don't really even have a clue right now how to represent them. And I think this is a good reality check. Wired's always running these things about how great AI is these days, but they reported on the Allen Institute's challenge to have systems do 8th grade scientific reasoning. The best scores were like 60%. You can get like 45% just by feeding things into Google, because many of the answers are kind of already there. But the rest of the way there is not very good. And so the way that Wired put it is the best AI is still flunking 8th grade science. Well, if you can't do 8th grade science, you're not going to be able to do high-level ethical reasoning. The point is not that deep learning sucks, which I'm sure is how people will paraphrase the talk. I actually think it's a pretty good tool. I use it in my company every day. But rather, the point is, as part of this I already said, we can't possibly hardwire in every ethical contingency. Unfortunately, deep learning is our best tool for automated learning right now, and it's maybe not the right tool for that particular job. We don't necessarily have another tool. So most of the research right now is on pattern recognition for images and speech. It's not clear that that transfers to something like an ethical principle. There's also a lot of problems. Peter Norvig just gave a couple of great talks on this that you can find online at MTech and O'Reilly AI about challenges in engineering large-scale machine learning. So how you incrementally build something, how you debug it, and so forth. It's not clear that for mission-critical jobs that these are the right tools. Building superintelligence is probably going to require the development of a lot of radically new tools that we don't even have a clue right now about what they should be. The nature of the cognitive machines that we create, how safe and unsafe they are, depends not on some overall IQ number like 120, 200, or whatever, but on the exact constellation of cognitive abilities they have and how those cognitive abilities interact with each other. And so, in a way, I'm pleading for thought on the texture of the particular entities that we're talking about. I don't think we can take for granted there's just going to be something with a 300 IQ and we can reason from that number. No two snowflakes are alike. Probably no two superintelligences are either. Who knows where we'll be, and I'm starting to wind up, where we'll be in 100 years, but until we have basic advances in building machine learning systems that can reason over abstractions, we're not going to be able to create systems that are capable of reasoning ethically. And so I think this is my last bullet point. Maybe the greatest fear shouldn't be superintelligence, which is in any case kind of long-term, but maybe something medium-term. Maybe superintelligence actually will be able to reason ethically. Maybe superintelligence will demand solving these problems about learning over abstractions and so forth that I've been pushing on. Maybe the thing we should most be worried about is the teenagers, basically, to connect this all back to the way I started. The teenage, immature, pre-superintelligence systems that have a lot of perception, which we're really good at right now, a lot of optimization we're getting really good at, and control, but not very much abstract reasoning. So thank you very much.
Worried that maybe we're the teenagers.
There's a good argument that humans have been, stuck in that way. You just look at humans from 200 years ago that thought slavery was fine, for example.
Question or two on this? Yeah, in the green.
So you observe that humans are sometimes inconsistent in their ethical reasoning. Do you anticipate that whatever representation a system we develop will somehow be consistent in a way that humans are not, or do you think that we'll ultimately need to develop a system that can allow for and resolve inconsistent preferences and concepts?
I think it's a great question. Humans are sort of our best model of ethical reasoners right now, and they're not that great. And we don't know whether there might be something better. So AI doesn't have to be human-like. There are things we want to learn from humans because humans can still do certain kinds of reasoning better and language better. But for example, arithmetic is much better left in the hands of machines. Maybe there will be AI systems that are better ethical reasoners, that are not caught up in cognitive biases and self-bias and so forth. So I think it's at least possible. At the same time, I think the issue you raise about inconsistency is really important. So one of the things that we do really well is to reason among inconsistency, find kind of reasonable compromises among that inconsistency, whereas like logical theorem-proving engines don't really have a way of dealing with that problem. The kind of deep learning stuff doesn't really have a way of doing that reasoning. So we're missing something in between where you can reason over a somewhat inconsistent world and not kind of give up. And so there's probably a hint from humans, and maybe we can do it better someday.
One more for Gary.
Francis?
Oh, Francis, yeah. Go raise your hand. We're good.
Hi. I was just curious, I mean, are there simple things? For example, philosophers discuss whether the numbers of people that will be harmed counts. Now, is it possible, for example, at this stage, to introduce something like, you can represent numbers of people, right? And
Sure.
presumably you could encode things like numbers are relevant, so that even if they had no concept of harm, okay, you would have to decide whether the entities were being harmed or not. Maybe that's something that you can see. But they could be taken to derive the conclusion that then, given that there's harm at stake, which you decide, numbers count, right? Or the way in which harm comes about. I was very surprised when Professor Kahneman said there was conflict over whether to push the fat man. Intuitively, I have no conflict at all. It would be wrong to do it. So if you could encode things like pushing someone over a bridge, or even, making it the case causally that someone falls over the bridge, that's something that they could recognize. You could decide that it would be wrong. They don't have to know anything about harm or the idea of wrongness or anything like that. They could be used then to limit their conduct on the basis of, well, he would have to be, thrown over the bridge rather than die as a result of something happening, like turning the trolley. These concepts are uncodable, aren't they? And they are morally relevant.
So I'm reminded of Jan's metaphor about, since he gave me a shout out for one of mine, I'll give him for one of his, which is about the cherry on top. So some of the things that you raised, I think the points are all well taken, are kind of like the cherry on top. So just counting numbers, yeah, machines can do that. And so it's no problem to have a utilitarian consequence, better to save the 5 than to sacrifice the 35 or whatever, if I said that right. But some of the things like pushing somebody over a bridge, I think, gets to my core point, which is you're probably not going to program in all of those contingencies. So, pushings over bridges might actually get hard-coded in somebody's ethics because there's so many trolley problems around. They're disproportionately represented in the literature. But, sorry, give me one more second. But a lot of other things that you could think of that aren't literal pushings over the bridges, nobody's going to directly code them right. And so then the question is, how are you going to have a system that has a rich enough understanding of a world to understand things ranging from physical reasoning, like if you push somebody in an elevator shaft, they will fall, and that will cause their death, right? To have the system actually make the inference that pushing someone in an elevator shaft is a bad thing if it's not hard-coded. And this is where I think, I see you want to follow up, but I'll just say one more sentence. This is where I think the rubber hits the road, and we just don't know how to have systems that are rich enough to make those kinds of inferences. So somebody might say, well, great, we'll put in a physics engine. Well, it's not so easy. I see Ernie Davis is here. Ernie and I have written a bunch about common sense reasoning, like getting a system to do the physical reasoning to realize that you put somebody in the elevator shaft and they're going to fall. Well, it depends if you've set up the problem correctly. People imagine these kind of like game engines that video games use.
Let's go back to Francis.
Sorry, it's true. This one more sense. I thought if I didn't take a breath.
Saving the 35, okay, by doing something first, which involves, harming the one. You could put in a side constraint there. Don't do it. If causally you can produce the end state of the 5 being saved, 35 being saved, and then the one will die. This is just a question of causal direction. Okay, you could get something closer to what I think is the right answer. People may disagree about what the right answer is, and I'm not asking the machine to do that. We crypto machines can figure that out. But if it's a matter of causal relations, you can get pretty close.
Well, we're not actually that great in AI at causal relationships. So, I mean, there are some formalisms for representing causal relationships, but typically some human is sitting there making a directed graph and labeling, what's the likelihood that the burglar alarm is going to go off if there's a person as opposed to a truck going by or something like that. What you would like is a machine that can, in an automated way, infer what causal relationships are at stake. So imagine my Turing alternative where you watch a video and you try to figure out causally what are the relationships between these characters and the props that they're using and so forth. And it's at the level of like parsing the scene and parsing the world that we really have trouble. Some of the abstract principles that ethicists propose, you could do that, but like the question of how to identify in this scene is there being a harm caused is actually the hard part. Eliezer wants to follow up on that, I think.
We, of course, tend to spend a lot of time talking about the things that we disagree about, but I think that's one thing that's worth sort of remembering what people do tend to agree about in this field. And I think that sort of like everyone with any kind of experience in artificial intelligence, I think basically agrees that any sort of real-world applicable values goals, it has to be learned, there has to be a learning rule. Like back in the early days of AI, we tried to hard code how to recognize a cat with logical rules. It didn't work. It's not going to work for values either. Like there must be a learning system and a learning rule. They cannot be hard-coded. There's just too much to generalize.
I mean, I think it's a nice way to think about it. So we have solved more or less, not completely, the problem of recognizing cats. There's this whole literature now about spoofing and adversarial cases and so forth. So I can devise a cat that a deep learning system will get wrong, but let's not worry about that too much. Let's suppose that that's mostly a solved problem. Can we use, in essence, this is what I'm asking, can we use the same techniques, or what kind of techniques do we need in order to recognize an agent in an action or a risk or a harm? Like, so the way that we are able to recognize the cat is we have a lot of examples, and we develop low-level, the systems automatically develop low-level features and then medium-level features, and they do it as a kind of hierarchical decomposition of features that are basically giving you information about things like texture and so forth. Is that same thing going to apply? I mean, I think probably there's some graduate student in this room who could make that a thesis topic. It'd be really interesting to try to say the same techniques. My guess is that they will fail, but I think that's okay. I think that we need people to think about what the alternatives are there.
Okay, now we'll go to a general panel discussion involving actually bringing in speakers and so on too. But I thought I might see if anyone on the panel has any questions or reactions for each other. It's not obligatory, but
I had a short one for Jürgen.
You have a reaction?
A short reaction to yours, which is compression is really cool. I like the architecture that you're talking about, but I'm not sure what it has to do with consciousness. The key really there seem to be self-representations, and GPS systems have that, but I wouldn't attribute them consciousness.
Yeah, no, the point is that you get self-symbols automatically by compressing just your interaction sequence as an interacting agent with the environment, and then the stuff becomes conscious as you are focusing your attention on it, or include that into the search space of the thing that you still haven't solved yet. As you're trying to solve a new problem, you have a search space. Now you have to try a couple of alternatives. Now suddenly you have in your focus of attention these few things that are relevant or seem to you relevant at the moment as you are trying to solve that problem. As you are then once you have solved the problem, the same thing is becoming automatized, and there are architectures which really do exactly that. So since 1991, where you have these consciously, I even had the words.
All right, if we're going to go history here, I'm gonna point to John Anderson's ACT-R model and its predecessors as another way of doing automatization, another way of having central focus of memory. All the properties you're describing are actually older than you described in the symbolic world. Just while we're doing history, but I wouldn't say an ACT-R model is conscious.
Don't omit the compression aspect. So to get abstractions, all of our abstractions about compression, either in space or in time or in energy. So you would try with fewer computational resources, encode the same history of actions, and as a byproduct of that, you get all these high-level concepts, which you I think you even said that we don't yet know how to get these abstract reasoning things. No, we do know how to get them. We do know how to get high-level spatial-temporal concepts that stand for things such as word phrases and, a plan of how to go from here to Beijing, not by simulating the future millisecond by millisecond, but, first going to this taxi station and then to the airport, and then for 9 hours nothing happens and we leave the airplane. So we do have these things going, and I'm not as pessimistic as you are. And what you mentioned
for me, it's a question about necessary versus sufficient. So for the sake of argument, I'm willing to stipulate that all that compression stuff is necessary and that self-records of some sort are necessary. I'm just not sure they're sufficient. So I can think of lots of AI systems of various sorts that have those things, but that I wouldn't want to attribute consciousness to. But I won't say any more.
Okay, let's open it up to audience questions. How about John?
So we have a bunch of people who study animal behavior in this question of conscious self-awareness, and they have tests for these kinds of things. So they don't think that there are lots of animals that I think satisfy what you would say they're self-conscious. They include insects. But when you tell an animal behaviorist that an animal is conscious, they often fight very hard to reject this. So this is meant to be a little cheeky, but how does your data compression algorithm do on the mirror test, for example?
Yeah, of course. Actually, all of this mirror neuron business is a natural consequence of data compression, because obviously, as you are a robot with pain sensors and whatever, and out there's your friend, another robot which looks a lot like you are trying to encode what you see about this other robot, and you are trying to do that in the most compact and most efficient way. And the one way of doing it right is to have something like a prototype robot, which can stand in for him, but also for yourself, and you only have to encode the deviations from the prototype. So the mirror neurons, of course, are those neurons that you can use not only to encode aspects of your own experiences, but also the aspects of the experiences of the other guy which you are predicting. So it's just more efficient to encode possible experiences of not only yourself, but also of the other guys by just having these mirror neurons. So I always thought this, Tononi and these guys, they are really misled, I believe, in coming up with these very complicated ways of defining consciousness, when all of this just falls out of data compression. Try to encode the same data with fewer computational resources, such as time, space, energy. And this is what unsupervised learning is about, and this is where you get the abstractions from. All of the abstractions, all of analogy is just a side effect of data compression. The emotional connect that you feel with another guy like yourself, because you can feel what he is feeling, is of course due to your predictions, which are based on your own experiences in the past. And there you can just reuse the same code, the same neurons, if you will, to model his experiences. So all of this is, again, just a natural byproduct of data compression.
I would just...
just a procedural note on what we're...
So I would just add it, of course, mirror test is different thing than mirror neurons. However, I think Jürgen's answer does apply to also mirror test, because you would be compressing your model of the world.
Just a procedural note on what we're doing in the lab.
Thank you.
What's that? Oh, that's all right. So just a procedural note on what we're doing for the last 30 minutes or so. I think you should not feel obliged to ask questions directly to these 5 speakers about their specific talks. It's also an opportunity for people to bring up more general issues on the theme of the conference, which might be partly directed at some of the previous speakers, who should feel free to take part in the discussion. So not every question has to be about the data compression theory of consciousness. Max.
So, despite the warning, let me mention the C word. So, David, there are many things I admire about you. One of them is your ability to sit and hear people say things about one of your pet subjects that you violently disagree about, with a total poker face, smiling, and then not even commenting, not even trying to set them straight or anything. But I don't have that. I don't have that level of inner peace developed. So let me just add something about consciousness. Everybody's entitled to their own definition of what consciousness is, of course. So, and many of the people on the panel, I think, define consciousness as some kind of ability to self-reference or say things about yourself or whatever. I, however, share with you this fascination for the question of understanding subjective experience. And to me, even if we can build machines that are very good at referring to themselves and acting exactly like Jürgen prototype 2.0 or whatever, and making us feel that they're conscious. I'm very interested in whether it actually feels like something to be that robot. And part of the reason, of course, is what Nick Bostrom brought up, issues with mind crime and so on. But I think there's another one that hasn't really come up very much at all, since you encourage us to think long term. Okay, suppose one day in the distant future, our descendants are some kind of machines. You know, this is not just science fiction, because when we look for aliens today, with a new $100 million funding or so, we take very seriously that we're most likely to find other civilizations that are actually some form of AI, because, you know, if something formed 2 billion years ago, it's not so likely that they're still going to be exactly in their biological form. So suppose that happens one day, you know, on Earth and in the cosmos, there's all these amazing life forms. Doesn't that make you feel warm and fuzzy? Maybe they have our values and speak our language and even read your books. You know, isn't that great? Except, suppose it turns out that they have no experience. They're zombies. There's no one home, you know. Wouldn't that be a bit of a bummer? And I think particularly people like Ray Kurzweil and others who take a lot of solace in the dream that they're going to upload themselves and become immortal, you know. If it's not so satisfying to do that, if you realize that there will be no subjective experience at all, and then the whole future of the universe is just a giant waste of space. So to me, this isn't just an idle philosophical speculation. And regardless of whether you want to call experience consciousness or something else, I think the question of what it is about a blob of quarks that makes it have a subjective experience is one that we really should study. We should be honest about the fact that we're pretty clueless about it. And it'll be relevant in the very near term if you're a doctor in an emergency room who has an unresponsive patient to figure out whether there's someone there. And it'll become more and more relevant in the future as AI progresses. So, little shout out to the hard problem.
Yeah, I agree. It's a very important topic, not just for the philosophy of mind, but for ethics. It actually reminds me of one of my favorite philosophical thought experiments, which is a mashup of consciousness and ethics. It's what I like to call the zombie trolley problem. So the trolley is going down the track, and on one of the tracks there's one conscious being, and on the other track there's 5 zombies. So otherwise, you know, functioning pretty impressively like humans, but let's stipulate they have no conscious experience. You've got the choice of which track to send the trolley down. Who's going to send it down so it kills the one conscious being? Hands up. Who's going to send it so it kills the 5 zombies? Okay, big majority. Now, next question. Now we've got our trolley set up on one track. There's one conscious chicken, and on the other track there's an entire planet of humanoid zombies. And let's ignore their instrumental relevance and all the things they might do for us, and so on. Who's going to kill the chicken? Who's going to kill the planet of humanoid zombies? It's like a scene from. It looks like that scene from Star Wars. But
Dave, what is the metric of consciousness here before I cast my vote?
How do you know what you're talking about?
It's a thought experiment. I get to make. It's a thought experiment. I get to make it up.
No, the thought experiment I buy completely, and the intuition I buy, it is clearly dependent on empathy, and empathy depends on the substrate. I mean, you know, having empathy for something made of metal is a lot harder than for something made of meat. So, how would you know? You're saying this question is very important. I mean, people have been saying that the consciousness question is the key question of our time for a long time. What would an answer look like? And how can a question be central when we have no idea how we would recognize an answer if we found it? We find localized answers in brain work on patients, and that is based on a correlation between 2 things: what they tell us and the brain, and then we can extrapolate when we see the same brain signals for somebody who's not talking. We can assume that being is conscious. Without that correlation, we can ask computers, but when the brain signal is not there, I really find it extremely difficult to know what we're talking about.
Here, I'm the optimist. I really think that there is an answer that we will recognize once we get it. I think I'm a blob of quarks, and I think if you put me in a some future really, if even today, if I sit in the MEG machine at MIT with 306 superconducting magnets, just reading out things, and I'm looking at a screen where the computer is trying to predict what I'm thinking about. You know, I can think about an apple and with maybe 90% probably get that right. I can do really serious scientific experiments and try to first see if the computer can predict which information processing in my brain I have an experience of and which I don't. And then this is the answer to your question. I think eventually somebody will have a eureka moment and come up with an equation and say, this is the equation that information processing has to satisfy in order to be a subjective experience. And then we can test that with all sorts of examples and gradually build confidence around it, just like we do with our physical theories. And when we feel really confident about it, we'll take seriously also what it predicts about computers and other systems where we can't rely on self-report. That's what I'm hopeful for. And I think the least we should do is at least try to find such a thing.
Would you hand the mic to Eric next to you? If it's on this.
Yeah, it's on this. Okay. So I guess my perspective is closer to Professor Kahneman's on this. I mean, it seems to me like we rely on intuitions about these things that are grounded in an evolutionary history and a social history that's based on a very limited range of cases. And then even when people try to apply science to it, here at the table, right, someone says, well, here's the equation, right? Or Tononi says, here's the equation, right? And then other people say, well, that's not, that guy's back there says, that's not my intuition. So we come at it with these very limited range of tools. If we're very lucky, we might find some convergence between what, you know, our philosophical intuitions are, what is kind of has various theoretical virtues like simplicity or elegance, what, you know, we can happen to discover through our scientific tools. And if we're lucky and get a convergence, then maybe we can all come to agree, but that might require more luck, epistemic luck, than is realistic to expect.
Okay, I have Wendell, then Eliezer, then Tom.
So I'd like to suggest sort of a functional direction for determining at least to what degree a system might have consciousness, and it's one that will actually accommodate Jürgen's perspective to some point. And that's that simply, I think most of us would agree that we're highly automatized beings. In other words, so much of the activity we do is, in a certain sense, our habit. It's programmed into it. It's happening through unconscious forces. But a lot of the function of consciousness seems to be to direct our attention to what cannot be handled through the automatized systems that we have. And therefore, it requires inspection. Now, there's some of those situations in many cases that just a little bit of attention, because we didn't quite catch what the situation at hand was, a little bit of attention will allow our automatized behavior to kick in, because it starts to recognize, oh, this is X, and I mistook it for Y. And that's a lot of what we're dealing with. But there's a whole flock of problems we come up with that the automatized system does not kick in at all. And that's because our information is lacking, there's information we can't have, there are factors that come into play that we don't fully recognize. And for me, that's what ethics is ultimately all about, is how we mediate in those situations where the automatized behavior can't kick in, and therefore we need to begin thinking slowly because we no longer have the automatized systems to handle. So it becomes very important, at least one test toward the direction of whether a system is really conscious or not, is whether it can go through those processes of coming up with a response to a situation at hand that can't be fully automatized in terms of the behaviors it already has.
Here I can comment, I think, as the oldest person here. When I was a student more than 60 years ago, we didn't think of consciousness in terms of action and deliberate action. This is relatively new, this way of thinking about consciousness. What we thought about consciousness was gestalt and perception, where you're essentially passive and you're conscious of the world. And that was consciousness for us then. Now, things have shifted in interesting ways, and I can't right offhand see, how and when it happened, but we're now thinking of consciousness in terms of deliberation. And that's a big change. But I don't think it's a necessary change. That is, for me, the consciousness when you're completely passive and you're watching something that makes no sense whatsoever, or listening to sounds that don't mean anything in particular, that is conscious. For me, at least, I feel I'm conscious when I'm having those experiences. How I would know that you have those experiences, I didn't know 60 years ago, and I'm no closer to knowing today.
So when I was 16, I read a really exciting paper that had a lot of influence on my thinking over the next several years. It was called Facing Up to the Hard Problem of Consciousness, or something like that. I forget who wrote it. This is I would actually say that the most important problem to solve is actually the inverse problem. How do we make something that we are pretty sure is definitely not conscious? Still pretty difficult, but if you have your AI that is sufficiently powerful coming up with hypotheses to explain the world, and the world contains people, we have to worry about the fact that the best hypothesis to describe a conscious being is much more likely than many other computations to be a conscious being, even if it's not the same conscious being. And I would also like to say a word of optimism about this seemingly utterly hopeless and confusing problem, because I'm such a famous optimist. And that is that if I flip a coin and I don't know how the coin landed, and I say 50% probability, my ignorance isn't a fact about the coin, it's a fact about me. A blank map does not correspond to a blank territory. I sometimes say that mysterious questions do not have mysterious answers. In fact, we've made that mistake many times through history, never with anything as on the same order as conscious experience and qualia, but life, like Lord Kelvin called it, infinitely beyond the reach of present science. How trees generate generation after generation of trees from a seed. He sort of he got a big emotional kick out of not knowing something, and made statements about its eternal inaccessibility, which were violated mere decades later. And that's because when you are confused about something, the confusion is part of the map. There's no such thing as confusion in the territory. In some way, we are confused about consciousness, and the way we will recognize our answer is when we know that we have stopped being confused. And there isn't going to be a fundamental barrier. It's just going to be something that we were confused about, and we will recognize the answer, because instead of the new theory of consciousness still giving consciousness a sort of sacred, inaccessible, opaque status and saying this is the ritual that matter performs to summon the inscrutable demon of consciousness, we will wake up and realize that we are no longer confused about the subject. Meanwhile, if you build an artificial intelligence and you need it to have some level of reflectivity, split it into two processes, have AI 1 being reasoning on the object level, have AI 2 being reasoning about AI 1, but if you can possibly avoid it, don't have AI 2 reasoning about itself, and enforce strict type discipline on the reflective process so that there's only AIs reasoning about other AIs, and hopefully that will prevent it from being conscious in the meanwhile, while we work it out.
Okay, I think maybe Tom Nagel may have a thing or two to say about consciousness.
This is a comment about a topic that has been largely absent from the discussion, although not entirely. There was some contact with it in Professor Kahneman's remarks, and Peter Railton took it up, and that is the epistemology of morality. And I think this is partly due to the fact that despite Dave's efforts, he couldn't get any moral philosophers except Peter to agree to appear on the...
To be fair, we had quite a number of applied ethicists and I'd say traditional ethicists, we struck out with about 10 of them, including Tom Nagel and Francis Cam. Many other members of the NYU philosophy department.
The peanut gallery. I think that a realistic discussion of these subjects has to acknowledge that we can't just talk about our values and how we're going to impose them on artificial intelligence. Ethics and value are highly contested domains of thought. One of the interesting things I find in this meeting is that there haven't been expressions of moral skepticism. That is the view that this is all complete nonsense and we should, forget about it. And I gather that Professor Kahneman himself isn't a moral skeptic. But if so, he must have some kind of moral epistemology by which he tries to arrive at the truth. So the acknowledgement that there are fundamental disagreements in ethics, although there are some basic widespread agreements about certain sorts of cases, but cases in particular in which there are conflicts between the interests of different individuals give rise to multiple contested and quite complicated theories. And the question of the process, what is the process by which we try to address these questions and perhaps seek agreement, is one of the things that hasn't really been part of this discussion. And the other is the big problem of how to make collective decisions in a situation in which there are fundamental disagreements over questions of value. And this inherits all of the issues of political theory that derive from this question. So in a sense, there is room for expansion of this discussion to take in a more complicated conception of the ethical background and its essentially contested nature, and also about the question of whether we should think of ourselves as discovering eternal truths when we engage in moral investigation, or whether this is a field in which things are changing and will continue to change.
In very partial answer to Tom, speaking as a developmental psychologist who's also an AI researcher, I think part of the answer here is that we don't want to instill the complete set of values and ethics in the machines. We want to give them some opportunity to do reasoning given some premise. I mean, I think it's the same thing as a parent. You don't want the child to be a carbon copy of you, but you don't want them to go off into random space either. We may be pushed in a similar position with the machines where we give them some guidance. We're basically building their innate apparatus and giving them their first dose of information, but then they're going to go out and reason over cases that they've seen in the world in some fashion. I think that's a very flawed system, right? Some people, their kids the kids do things that they wish that they hadn't, right? Some of them grow up to be murderers and so forth. And one of my fears in this general area is we might develop systems for essentially moral education for robots that are like 90% efficient or effective, if you can even have such criteria given your question. But what about the other 10%? And what about the scaling problems? How many bad machines there, quote, bad machines there have to be in the context of a lot of ones that have learned the things that we want before we get really, really worried. So I think there's like a developmental, in the psychological sense, piece of an answer to your question. It's by no means a full one, but it's one way to think about it at least a little bit.
Just one sentence. one of the points I was trying to make was that indeed values are contested, and they're contested within the individuals, not only between individuals. That was, if there is a basic inconsistency, it's a different problem than the problem of resolving differences among people.
Anyone else want to comment on this? Anything direct? Oh, Francis, go ahead.
I didn't want to come in on this, but
Go ahead.
well, I don't think, well, with respect to the inconsistency issue, I think that, you know, as Tom himself has pointed out in an article on moral pluralism, that there may be different considerations that people have to take account of in making a moral decision. But that doesn't mean that there's necessarily inconsistency. So the fact that there seems to be conflict between, you know, should I take care of someone's rights or should I look at the consequences, or what about my virtues? You know, if that's, I'm not sure that that's what you mean by, you know, internal incoherence, but that's not taken by philosophers to be a sign of internal incoherence. I actually wanted to ask a question about consciousness. May I get a chance at that?
Sure, go ahead.
The thing is that this has to do with bioethics in a sense. There is this investigator, a moral bioethicist doctor at Cornell Wild, John Finns, I think his name is, and he's recently made clear that people who are declared to be unconscious, perhaps this is a question for you, I forgot your name, I'm sorry, Susan. People who are declared to be unconscious, in the sense of, you know, test of consciousness that we use. If they're asked, can you pretend that you're hitting a tennis ball? The areas of the brain that are usually involved, okay. So, and they respond. They seem to respond even to questions like, you know, do you think your mother's still alive? Yes, no, right. Now, if these individuals are unconscious in your sense, all right, and this is maybe related to your question, David, you know, suppose that permanently we were like that. In other words, we were functioning in a way that was really pretty high level. And I don't know whether they asked them to prove Fermat's last theorem, and maybe they can do it when they're unconscious. The point is that, you know, if we were systems like that, or you take that person in the hospital room, and the reason this came up was, the question is, well, should we pull the plug on him, all right? He's been unconscious for years. And then all of a sudden, they discover that he's responding to these questions, okay? And they don't pull the plug. So the thing is that if in the case of human beings, we find unconsciousness, but with the same sorts of responses to questions or whatever, right? Do we want to extend the concept of consciousness, or say that someone who was once conscious, when they fall into this state, has different rights than someone who was forever from the beginning that way, you know? I don't know what anencephalics can do. You know, can they respond to these questions? The point is that there could be human systems that are unconscious in this sense, but are functioning the way AI systems work. And we don't treat them like we're treating, or we think we ought to treat AI. We're treating them differently. We're not pulling the plug on them. So that was my question.
Susan?
I love that. So I love that point. I think we have to bear it in mind. You know, this whole conversation on machine consciousness just leaves me struck by absolutely, it's going to be incredibly difficult to figure out how an AGI or a superintelligence that's structured so differently from us is conscious. I mean, we can't even figure it out in these tricky cases. And I mean, I think what you said is an excellent point. We need to bear that in mind.
Just on the patients in vegetative state, this was actually the main subject of our center's conference 2 years ago.
I'm sorry,
measuring.
I've been at many conferences, especially if they're held during the daytime.
I'm sorry.
But I didn't know if I was repeating.
Okay. Yeah. Next time we're holding the conference at midnight for you, Francis. Yeah. But in fact, this subject was very much under debate at the on those patients who showed the brain response associated with imagining playing tennis or imagining walking through your house. I think the standard view on this is that is a sign of consciousness. So it's not going on unconsciously, although certainly there's a lot of debate and dispute among neurologists. But actually one thing that came up at that conference among neurologists is they're a lot better, and this connects to a point that Eliezer was making. We're a lot better at getting things that look like evidence for consciousness than things that look decisively like evidence for lack of consciousness. And if you look at the tests that neurologists use for what they call the absence of consciousness, they're terribly unconvincing on philosopher's grounds, things like really complicated stuff like planning and goal-directed behavior and so on. Nothing like that we think is needed for consciousness, simple pain, simple sensory experience. We really don't have very much in the way of decisive tests for the absence of consciousness, which, it is true that a number of processes seem to be done unconsciously by the human cognitive system, which gives rise to the possibility that AI systems may be doing that consciously, but maybe doing all those things unconsciously. But speaking for myself, a lot of people recently have taken seriously the idea that consciousness goes all the way down the natural order, and there's some element of consciousness even in very simple information processing processes. Something like Giulio Tononi's view has that consequence, for example. I don't think we're in a position to rule that out, and that really does start to raise the question that what matters morally isn't just the presence or absence of consciousness per se, but the kind of consciousness, the character of consciousness, and certain forms of complex consciousness embedded in cognition, for example. So I think, much as I would love all the ethical issues here to be about consciousness, I think that might just be the beginning of it.
Yeah, I mean, the thing, may I?
Sure, go ahead.
The thing is that, you did your experiment, your thought experiment trolley. You had a bird on one side and the Grand Canyon on the other. I don't think anybody thinks the Grand Canyon is conscious, right? I would say the Grand Canyon rather than the bird. I mean, it's nothing conscious. It's always at the same.
Very good. Okay, I would say we're pretty well at the point where the conference is coming to an end. Can I get Ned and Matthew and John Simon up here? Just got a few words of thanks to people to end the conference. It's been a wonderful thing. We want first of all to thank all of you for coming, to thank all of our speakers and panelists. I'd like to give a shout out to all the helpers we've had for the conference. You've seen Ileana and Joe and Albert running around the auditorium, and downstairs we've had a whole bunch of others.
Cassie and Jennifer.
Cassie and Jennifer and Lee Bond have played a very central role in administrative support for the conference from bioethics and from the philosophy department. Are there any other crucial volunteers we should name? Yeah, all the bioethics students and volunteers have been fantastic, and a whole lot of support. Really, the key role in getting all the legwork for this conference together, and endless emails and running tasks for months on end, has been this man here, Jonathan Simon, who really deserves a big round of applause. And finally, Matthew, Ned, and I would just like to thank all of you for coming, and all the speakers for coming, and I hope you've been stimulated to think really interesting thoughts about the ethics of AI for some years to come. So cheers.
And let's not forget to thank the indomitable David Chalmers as well.
Interesting.